Hi guys, today I want to talk about Java parallel programming utilizing the Java fork join framework. And I want to start this conversation by introducing you guys the idea for need of speed. As our current market stands, that the clock speed of our CPU is reaching a bottlenecking situation, which each new generation of the CPU that come out for the past couple years is not as promising increase of a CPU performance for each single core as relevant as several years before. So people might say that, okay, so our current physical CPU is not really doing as great. How about quantum computing? However, my argument for that would be the quantum computing is a really promising and great research area where it will return a very promising result. However, the chances of quantum computing being commercialized that for day-to-day usage and then smaller businesses usage is not very likely to be happening for the next 20 to 30 years. So now the only options that we have is to utilize our current given consumer grade machine with the multi-core processors to even further speed up our computations given a large amount of data for processing. So now I can introduce you guys the idea that Java can help on that. So what is the Java fork join framework? Java fork join framework is mainly divided into two different big parts, which is Java fork join pool and Java fork join task. The fork join pool is an executor service that runs the fork join task, and then the fork join task is mainly a base class for the fork join task framework. And then under the fork join task, there's two subclasses which are called recursive action and recursive task. Both of those two things are a subclass of Java fork join task, which for both of them, they're abstract class which you have to implement an abstract method called compute in order to do its computation. The difference between those two things is that recursive action is a resultless recursive task, and then recursive task instead returns the result. So how does this work? In a big picture sense, for those of you that have taken 361 or are taking 361, you already know the basic idea of parallel programming, where you have a bigger task and you further divide the work until a certain level, and then you do the computation and merge back the result. But in the sense of Java fork join framework, it is dividing the work utilizing the instance of objects. So you will be creating a big task objects, which it will further divide into smaller instance of that object holding smaller pieces of the data to process and its own local variables and instance of the data that you needed, and then it further divide into smaller pieces, and for each level of the division, it waits for the result of its children's to return back the result. So at the very bottom level, where for a single task to be small enough for our CPU to do its work, we just do the work on the smaller data sets and then return back its data to its parents level. And once the parents level receive all the necessary information, it returns its partial result to its parents level, and so on and so forth, until we finally join back to one final instance of the object which will hold the final result. So on the code level, here is a piece of example code for implementing the recursive action. So for this abstract class, we are creating an instance of class extends the recursive action, which in it will hold some temporary variables such as thresholds, helper functions, and whatever you need for the computation. And the most important part is to implement the abstract method called compute. In this instance, we're using the recursive action, which means that we're not returning anything, thus making this method compute avoid function. So inside the compute, basically is asking you two questions. Is the given amount of work small enough? If it is, just do it. Else, if it's big enough or it is relevantly big, then we split the work in half, create two smaller instances of the objects, invoke them all, and wait for the result. So I've written a piece of code that utilizing the Java fork join framework to do the merge sort operation. And for my program, there are some specific things I want to mention. Is that I set the threshold to about 10 million elements of the array, and then we'll be testing out different sizes given the threshold and analyze the time between the regular merge sort and then the merge sort utilizing the Java fork join. So now let's do it. So in here, let me make sure that I cleaned everything. And now we can see that there's a sort, the parallel merge sort.java file, and then the demo file. So let's take a look inside the merge sort. So in here, it's pretty much a class of merge sort extends recursive action, which holds its own threshold and some of its local variables. And then here's a constructor for the class, and then inside here is my implementation of compute, which given the high indexy and then the low index, if the number of elements within the range is smaller than the threshold, I just sort that section of the array. Else, I divide the current section of the array that I'm looking at into two, and create two new instances of objects that holds the left half and the right half of the array, and invoke both two objects, wait for the result to turn back. After I get the partial result for the left and the right, I merge those two temporary arrays back together. As you can see, the beauty of Java fork join framework is that you don't have to deal with all the threading and all the little nitty-bitty parts of parallel programming, which the Java fork join framework handles all of that for you, and all you need to do is just to develop the algorithm to run it, to avoid the logging and time performance issues. So now here's a function to merge two temporary array back, which I believe all of you guys taken 251 before, so this should be a piece of cake. So now let's actually compile and then run the code. So I'm gonna first be testing out the array size of 10 million to see, given the array with the size of just a threshold, what is turnout. As you can see that the performance between those two, the fork join and the regular merge sort, is really similar. The reason behind it, you guys probably already know. It's small work, which you just do it, and it will take more time to create the threading and then the instance of class rather than just doing the merge sort on a local instance. So now, if I change the size to 4 times its size, you can see that it's taking a longer time to initialize the array, and it takes about 2.8 seconds for Java fork join, and it's taking a lot more time for the regular merge sort, which is about roughly 2 seconds longer, which you can see dramatically increase in performance for utilizing the Java fork join framework. So now, you might want to ask yourself, is this parallel programming method really for you? So here are a couple questions you might want to ask yourself. Is Java really for you? A lot of people like different style of coding. A lot of people like Python for simplicities. A lot of people like C, C++ for its power, and then being able to control a lot of the nitty-bitty details of your code. So maybe Java is or isn't your thing. And also for the style of programming, since this is more of an object-oriented parallel programming method, maybe it is a little different than just doing it in order or dealing with this without creating instances of objects. And since the style is different, the algorithm approach for creating the parallel programming is also slightly different, but should be quite similar, but still a decent amount of difference. And then also there are some cons for this type of programming, which every single time, since we're dealing with object creations, that we are needing to store all of its temporary variables and data for each instance of the children objects, which might create a problem of memory usage, since we are dealing with huge amount of data and a lot of data processings. So think about if this type of programming style is really for you. And now here are some final thoughts that I want to bring back. First, I want to mention it again that parallel programming is now the physical limitation of the CPU is reaching its bottleneck, and for the next 20 years, maybe even longer, parallel programming is the way to go for dealing with huge amount of computation needs. And also, I want to briefly mention that Java is still doing it. Even though after 20 years it have came out, the framework, the language itself is still keeping itself on the market, following the trend, introducing new ideas. And I just, for the last but not the least thoughts, is that we need to learn new things every day. We are the future of the field of technology. If we can't even keep up with our current technology, how can we make the future? So we should learn new things every day, and when it's our time to shine, we will make a difference. And thank you for listening.